All right, guys. So now we're going to move on to solving systems of equations. So a system means there's two variables. And if we just have one equation with two variables, you really can't solve it. That's where we graph lines with infinite amount of solutions. But when you have a system, that essentially means you have two lines that are intersecting at a point. And that actual point is the solution of the system. And all systems have either one of three options. They either have one solution, they have infinite solutions, or they have zero solutions. There's no system where there's like three different answers. Most commonly, you're going to get one answer. So in the first system, it's probably the simplest one because the y is already by itself. Y equals x plus 3. We can take that x plus 3 and plug it into our other y. And now I have a single variable equation. 5x plus x plus 3 equals 27. We combine our like terms. 5x and x is 6x plus 3 equals 27. And now it's basic algebra. We subtract 3, divide by 6, and our x equals 4. And once we have our x, we can plug it back in and get our y. 4 plus 3 is 7. So our answer here is 4, 7. X is 4, y is 7. When you're doing a system, you always have to take your one answer, plug it back in to get your other answer. Okay, so please be aware of that. And secondly, keep in mind, you're still in the end only solving a single variable equation. What we're doing is manipulating it, two variable system, into a one variable equation that can be solved. In our second one, it's not so easy because they don't solve for y for you. You can either use substitution or linear combination. I'm a bigger fan of linear combination, so that's what I'm going to use here. And essentially, I've got to get the same number in front of one of the variables, either the x or the y. And once again, it's kind of like getting rid of fraction. I get to make the choice what I'm going to get rid of. So always pick what's easier. You don't get bonus points for degree of difficulty. So in this case, if I want to get rid of the x's, I'd literally have to get what is the lowest common multiple between 3 and 7, and that's 21. So I'd literally have to multiply the top by 7, the bottom by 3 to get the same number in front of the variable. I don't want that. I'd rather work with 2 and 1. If the numbers are 2 and 1, the smallest number that 2 and 1 both go into is 2. Now, I put a negative 2 out here, and the reason why is I always want opposite signs in front of my variable I'm going to get rid of because I'm going to add. So if you already have opposite signs, you multiply by a positive. Since you have same signs, you multiply one of them by a negative. And you have to multiply everything through. Once again, the golden rule of algebra, what you do to one side, you have to do to the other. So when I multiply through by negative 2, I get negative 6x. Negative 2 times negative y is a positive 2y. And negative 2 times 10 is a negative 20. And now I'm combining with my 7x minus 2y equals 23. What's nice here is the 2y's cancel. Negative 6x and 7x represented by x. And negative 20 and 23 is 3. So my x equals 3. And then I always plug back into an original. 3 times 3 minus y equals 10. So 3 times 3 minus y equals 10. Therefore, 9 minus y equals 10. Subtract 9 on both sides. I get negative y equals 1. And I multiply both sides by negative 1, and I get y equals negative 1. And that's how I solve my system. Now, the last system is probably the hardest one to do. So I'm going to make it a little bigger here for us. All right, and that's when you have 3x plus 5 equals negative 9 and 4x minus 3y equals 17. These are the toughest problems because you have to multiply both equations by a number. In this case, I chose to get rid of the y's again. Once again, you can get rid of the x's as well. The reason I chose the y's is I already have opposite signs. So therefore, I don't need to multiply through by negative. If you had same signs, you'd have to make one of these numbers negative. Wouldn't matter which one, but you'd have to make one of them negative. When you already have opposite signs, you don't have to make one of these numbers outside negative. Now, essentially, I take the number in front of y and I multiply it by the top. Take the number in front of y here and I multiply it on the bottom. Okay, you can always do that. Now, sometimes there's an easier number to work with and you don't have to do that. But I can always guarantee something's going to get eliminated by taking this coefficient, multiplying it on the bottom, this coefficient, multiplying it on the top. When I multiply through, I get 9x plus 15y equals negative 27. When I multiply through, I get 20x minus 15y equals 85. And when I combine my like terms, 29x, the y's cancel, and negative 27 and 85 is 58. We divide both sides by 29, and my x equals 2. And now I plug back into an original. 3 times 2 plus 5y equals negative 9. 6 plus 5y equals negative 9. You divide by 5 on both sides, and y equals negative 3. And if you want to check your work, and you can do this in all of them, you take your point and plug them into both equations. It should make both equations true. 3 times 2 is 6. 5 times negative 3 is negative 15. 6 and negative 15 is negative 9. 4 times 2 is 8. Negative 3 times negative 3 is 9. 8 and 9 is 17. So therefore, I must have done it correctly.